Hello everyone. Now, we're going to be exploring a somewhat new concept in this modular arithmetic system by first exploring the following problem. We want to find the greatest multiples of 12 less than or equal to each of the following integers. Okay? So 137, 97, 68, negative 97, 177, negative 46, so on and so on and so on. So, what are the greatest multiples of 12 that basically approach each of these values, but are equal to or less than them? But the greatest one. So, for instance, 137. 137. Well, 11 times 12 is 132. But if I were to do 12 times 12, that would be 144. That would be too great of a number to use. So I would have to use 11. 11 times 12 gets me about to 137. 97. Well, I mean, I know that 12 times 8 is 96, and I'm pretty sure that's as close as we're going to get. So 8 would be the closest multiple of 12. 68. Well, 5 times 12 gets me 60. Another 12 would get me 72, so I'm going to have to go with 5. Negative 97. Well, I know that 9 times 12 is 108. And, what was it? 9 times 12 is 108. 8 times 12 is 96. But, it's a negative 97. So, 12 times negative 9 is negative 108. And 12 times negative 8 is equal to, getting a little ahead, negative 96. But I want the greatest multiple that's less than or equal to negative 97. Now, where does negative 97 fit here? Do I go with, like in positive terms, I would go definitely with the 8, because 96 is less than 97. But, as we all know, hopefully, negative 108 is certainly less than negative 97. And 96, negative 96, is certainly greater than negative 97. So in this case, we want to go with negative 9. Because negative 108 is less than, it doesn't go over the negative 97. Continuing onward. 177. Well, 14 times 12 is 168. Another 12 would be 180, too much. So I'm going to have to go with the 14. Negative 46. 12 times 4 is 48. So 12 times negative 4 would be negative 48. So that is as close as we're going to get while being less than negative 46. 124. Well, I know 10 times 12 is 120. So that's probably the closest. 43. 3 times 12 is 36. 4 times 12 is 48. And 48 is too big, so I'm going to have to go with the 3. 238. 238. 12 times 19 is 228. 12 times 20 is 240. Too big, so I must go with the 19. And I'm just going to go through the last couple fairly quickly. 72 would be 6 times 12 would get us close. Then 102. 102 would be 8. 8 times 12. 39. 39 giving us the 3 times 12. Whoop. Okay. That's it for part A. Part B says, write each of these integers in the form of 12n plus r, where n and r are integers, whole numbers, and r is strictly less than 12, but greater than or equal to 0. So basically, write it in that division algorithm type form. So I'm going to sort of list them out in the order of their remainders, starting with 72. 72 is equal to, well, we already figured out that would be 12 times 6. And 12 times 6 is 72. So I have to add nothing to it. And again, we're listing them in forms of like, in this case, A is equal to 12n plus our remainder of r. Now the next one I'm going to list is 97, which is equal to 12 times 8. And 12 times 8 is 96 plus 1, giving us 97. Next one is going to be negative 46, which is equal to 12 times negative 4 plus, well, 12 times negative 4 is negative 48, so it would have to be plus 2 to get us negative 46. And for the next ones, I'm just going to list them out without really thinking too much about the math. So we have, next one would be 39, which is 12 times 3 plus 3. Then we have 124, which is equal to 12. 12 times 10 plus 4. Then my next one is going to be 137, which is equal to 12 times 11 plus 5. My next one is 102, which is equal to 12 times 8 plus 6. After that, we have positive 43, which is 12 times 3 plus 7. 68, which is the same as 12 times 5 plus 8. Then we have 177, which is 12 times 14 plus 9. 238. 238 is going to be the same as 12 times 19 plus 10. And then finally, negative 97 is the same as 12 times negative 9 plus 11. So as we can see, I listed the remainders in ascending order to make just a little bit advanced, because it's going to make part C fairly easy. So arrange the following integers in pairs that are congruent to modulo 12. Now, again, if things are congruent in a modular system, we discovered that what we're really determining is what is the remainder when divided with 12. Or we have that system where, like, let's say, I'm going to take 97 for instance. 97 minus the number I think it's going to be congruent with, which is going to be like a 1 in this case, since that's my remainder, over 12. Well, that is going to be the same as 96 over 12, which is 8. An integer. So that shows the congruence. So I know that 97 is congruent with 1 mod 12. And since we have discovered all the remainders, we know the congruences already. So we got that 72 is 0 mod 12, and because it's a nice perfect multiple of 12. Negative 46 is congruent to 2 mod 12. $39 is congruent to 3 mod 12. 124 is 4 mod 12, and so on and so on. 12. Alright, that messed it up a whole lot. Alright, me being lazy never pays off. Alright, keep going. 5 mod 12. Then we have that 102 is 6 mod 12. 43, 7 mod 12. 8 mod 12 for 68. 177 is 9 mod 12. Uh, 238 is 10 mod 12. And finally, negative 97 is 11 mod 12. So those are all the pairs that we have. Negative 97 pairs with 11, 238 pairs with 10, so on and so on. You can just find it, you could have done the division by brute force, like for instance 137 when divided with 12. 137 divided with 12 is 11 with a remainder of 5. So we would know that 137 is congruent to 5 mod 12. We could have done it that way, but the problem was sort of guiding us to seeing the conclusion on our own. And of course, this establishes 137 is congruent to 5 mod 12. Now, this will lead us into a new concept called the residue. We say that R is the modulo M residue of N when N is congruent to R mod M and that R is between 0 and M, not including the M. So what that means is that if R is a residue, then it's strictly less than the modulo number that we are working in, which basically amounts to the fact that it's the remainder of the division by 12. So like for instance, I don't know, we don't like 72, right? 72 is congruent to 24 mod 12. However, 24 is not a residue. Why? Because it's certainly 24 is certainly greater than 0, but is it less than M, in this case 12? Well, no. It has to be less than 12. So what is the residue? Well, 72, yeah, sure, they're congruent with 24, but the residue in this case is 0 under mod 12. Because this is the lowest form of the congruence that we can get, where 0 is, well, yeah, it is greater than or equal to 0, and it is less than 12. So it fits the criteria. So we will explore the cool properties of the residue in future videos, so stay tuned.